We are so excited for August 21st. What's going to happen is the moon is going to cross in between the sun and the earth, and we're going to be treated to a spectacular show as that shadow goes across the earth. Everywhere in North America, Central America, and even bits of South America will get to see some portion of the eclipse, either partial or total. If you're in the path of totality, that's going to be especially amazing because what happens is the moon will totally block out the main body of the sun, and you'll get to see the sun's atmosphere, the solar corona, around the moon, and it's just going to be amazing. That's correct. Never look directly at the sun, even with sunglasses on. What you want are safety eclipse glasses like these. And you can check to make sure that your eclipse glasses really are safety eclipse glasses by going to our webpage, eclipse2017.nasa.gov. And on that webpage, we'll have information on how to check. So for example, you want to look for an ISO number. Cross-check that with what we have on our webpage, and a manufacturer. Again, cross-check that with our webpage. During totality, if you're in that path, you can take off your glasses and look directly at the sun during those couple of minutes. The other thing you can do is indirectly view the eclipse. So you can do that by creating a pinhole projection. You can do that with your hands and create a little pinhole with your fingers there. You want to stand with the sun at your back, let the sun shine through your pinhole, and then the image of the sun and the moon taking a bite out of the sun will be projected down on the ground in front of you. You can take off your solar glasses when you don't see anything any longer. That means that the moon has blocked out the main body of the sun and the atmosphere around it is now visible. Then, as soon as you start to see the sun peeking around the moon again, you need to put those glasses right back on. So if you're not in the path of totality and you're going to get a partial eclipse, that's still really amazing. What's going to happen is the moon is going to go across the sun and take a bite out of the sun, creating crescent-shaped shadows, and you'll be able to see those with pinhole projector. You can also see those even if you stand in front of a tree. The shadow, as it goes through the tree acts like a pinhole projector, and you'll get images of the moon going across the sun in the shadow of the tree, and you'll be able to see that. I am so excited about this eclipse because I study the solar corona. The solar corona is the part of the sun that we get to see during a total solar eclipse. It's the atmosphere of the sun. And it's much less bright than the photosphere, the main body of the sun, so we usually don't get to see it. I get to study it with NASA's spacecraft that watches the sun all the time, but this total solar eclipse, getting to see it in person and getting to see it in this particular way is so exciting to me. NASA.gov/Eclipse Live is doing live coverage of the eclipse, of the path of totality. We have stations all across the country watching the total solar eclipse, and we have airplane coverage of the total solar eclipse. So whoever gets to see the eclipse, we will be covering it, and we'll have coverage of that. So if you're in the partial phases of the eclipse, or if it was clouded out in your area, check us out and watch our live coverage of the eclipse. An eclipse only lasts for a couple of minutes because of the precise geometry. We have to get this perfect geometry, this perfect lineup between the sun, the moon, and the earth. And to get that to line up just exactly perfect, the shadow at a given place on the earth only lasts a couple of minutes. As the eclipse happens, it's effectively turning into night in just a small location on the earth for just a brief period of time. And that's really strange. The atmosphere is going to respond and become cooler. The cloud coverage could change, the ionosphere could change, and we have an app called Globe Observer app, and we're encouraging citizen scientists to tell us what is going on, what they are observing as the eclipse is happening. So if you have a thermometer and you get the Globe Observer app on your phone, then you too can be a citizen scientist and help NASA collect data on how the Earth is responding to the eclipse. In fact, we do look back at the Earth during the eclipse. We have a spacecraft, one of them is called Discover, and it sits in between the sun and the Earth, watching the Earth, and it will watch the eclipse as it happens. It will watch the shadow of the moon cast across the Earth and go across the Earth. Lunar Reconnaissance Orbiter is another mission that usually watches the moon, but for this eclipse, it's going to point and look at the Earth, watch the shadow of the moon go across the Earth. And the International Space Station is also going to get to see the shadow of the moon go across the Earth. Lunar Reconnaissance Orbiter has taken very precise measurements of the moon. It has precise measurements of the topography, the mountains, the valleys, the craters, because the moon is not a perfect sphere, and so the shadow that it casts down onto the Earth is not a perfect circle. The details of the topography are what help us know exactly what that shadow is going to look like when it hits the Earth. You can learn more at eclipse2017.nasa.gov. That's where we have all sorts of information, everything from safety to detailed maps of what you're going to see in your area. We also have event information. Local libraries, zoos, museums, things like that are hosting eclipse parties, and you can find out what events are going on in your area.